A certain engine part of iron expands 1 millimeter in length as engine warms up. So that means we have delta L of iron equals 1 millimeter, and then suppose that initial length of this piece of engine part is L iron, which we don't have a numerical value for. What would be the approximate change in length if the part were made of aluminum instead of iron? So it's asking us to find the change in length if it were aluminum. So because it says if it were an aluminum, that means the length of the iron of that part, engine part, is the same in iron and in aluminum originally. So I'm going to have this equals L aluminum. Okay, this is kind of the important part in here, because it's the same part. Whether it's aluminum or iron, it should have the same length. What else do we know? Because it's a thermal expansion, we know the coefficient of thermal expansion of iron and aluminum. So alpha of iron equals 12 times 10 to the negative 6 over degrees Celsius, and alpha of aluminum equals 25 times 10 to the negative 6 over degrees Celsius. So it's a thermal expansion. What we know about thermal expansion, we know that delta L equals alpha L delta T. So as you can see, we don't have any temperature change in here. So, but we know one thing, that the temperature change in both cases are the same, whether it's iron or it's aluminum. We're interested in change when the temperature changes at the same amount. So delta T for aluminum and delta T for iron should equal to each other. Okay, so let's write delta L for aluminum equals alpha aluminum, L aluminum, delta T aluminum. Delta L for iron equals alpha iron, L iron, delta T iron. Okay, so let's call this equation 1. This is equation 2. Divide 1 by 2. Equation 2, we can write delta L aluminum divided by delta L iron equals alpha aluminum L aluminum delta T aluminum divided by alpha iron L iron delta T iron. So let's see what we have. We have that L iron and L aluminum are equal to each other, so these two will cancel out. We also have that delta T aluminum and delta T iron are equal to each other, so these two will cancel out. So we will end up having delta L aluminum over delta L iron equals alpha aluminum divided by alpha iron. Now remember, we are looking for change in length of aluminum. So to do that, I'm going to multiply both sides by delta L of iron, so I can get rid of this delta L on the bottom. So this will cancel out, and then I will end up having delta L aluminum equals alpha aluminum divided by alpha iron times delta L of iron. So let's plug in now the numbers. So alpha aluminum is 25 times 10 to the negative 6 over degrees Celsius. Alpha of iron would be 12 times 10 to the negative 6 degrees Celsius. Delta L of iron is 1 millimeter. I'm going to keep it in millimeters because it will cancel out. The degree Celsius cancels out. The answer will remain in millimeters. So if you punch this into a calculator, you will get this equals 2.808 millimeters. So our answer is that if that was an aluminum instead of iron, the exact temperature change will increase the part double, 2 times more than if it were an iron.